Good day, Bayaws! Welcome to our YouTube channel, Bayaw Tutorials. In this video, we are going to solve a problem in Chapter 6, Fluid Flow Measurement from Fluid Mechanics and Hydraulics, 3rd edition by Badillo. Fluid flow measurement. There are numerous numbers of devices used to measure the flow of fluids. In any of these devices, the Bernoulli's energy theorem is greatly utilized, and additional knowledge of the characteristics and coefficients of each device is important. In the absence of reliable values and coefficients, a device should be calibrated for the expected operating conditions. So our sample problem here is related in a venturi meter. So here's a problem. A 75mm by 37.5mm venturi meter is installed in a 75mm pipe to measure the flow of oil with a specific gravity of 0.853. A differential gauge connected with inlet and throat contains water in the lower part of the tube, the remainder of the tube being filled with oil. The difference in height of the water column in the two legs of the tube is 560mm. If the coefficient of meter is 0.957, compute the change in pressure head between 1 and 2 in meter of oil. So, here's our figure. By solving this problem, we need to apply the Bernoulli's energy theorem. So we have P sub 1 over specific weight plus height minus 0.56 divided by 0.853, which is the value of our specific gravity, minus height minus 0.56 is equals to pressure 2 divided by specific weight. So, canceling the height because they are the same. So, P1 over specific weight minus 0.0973 meter. This value is equates to 0.56 over 0.853 minus 0.56. So, here, by simplifying this equation, we can now solve for the change in pressure head between 1 and 2 in meter of oil. So we have P sub 1 minus P sub 2 over specific weight is equals to 0.0973 meter. So here's the answer for the change in pressure head between 1 and 2 in meter of oil. So, I hope you learned something from this video. Thank you.